This is a recording on organic chemistry. It will cover targets 4.7b, writing the names of hydrocarbons, and 4.7c, identifying functional groups for carboxylic acids, esters, and alcohols. Okay, let's take our first condensation reaction. Generically speaking, it's a reaction between carboxylic acids and alcohols, and it produces an ester and water as a result. So these would be the reactants, and these two to the right of the arrow would be what gets produced, the result, which we call the products. How do you know? By looking at the formula. If you are looking at the chemical formula, if it's the acid, the alcohol, or the ester. We call these functional groups. Okay. So for example, for the carboxylic acid, they all contain carbon as their central atom. And for the acids, we have a double bonded carbon to one oxygen. And then we have a single bond leading to an OH group. In addition, there'll be some variable group hanging off the end here. And when the reaction happens, that will get switched to another group. So this R stands for variable group. And to vary, it means to change. So it could be a number of things. How do you know you're looking at? So this is the, let's see here, the functional group for the acid. And it's a Cu with an H group, and this is the acid. That's how you know you're looking at the acid. How do you know you're looking at the alcohol? Well, you look at its functional group, and its functional group also contains a carbon with an OH bonded to it. And then it has an R group hanging off here. So this is the functional group for an alcohol, COH group, and that's the alcohol. So you need to be able to identify them when used in an equation, a condensation reaction. And what gets produced is some water, H2O, plus another carbon-containing molecule or organic molecule substance called an ester. And how do you know you're looking at an ester? Well, an ester has a double bond to an O and one single bond to an O with an R group hanging off it. You can have an R group hanging off this one, and you could have an R group hanging off this one. However, the functional group, and how you know and identify it as an ester, is the Cu group, COO group. And this is a functional group for an ester, the Cu group. Okay? So how do you write the names of these hydrocarbons? How do you know about their structure? Well, some examples might be writing names for hydrocarbons. Okay? We use what we call prefixes. each prefix is associated with the number of carbons present in that molecule. So the number of carbons is identified by the prefix. For example, if we have methanol, that prefix, meth, means 1. Eth means 2. Prop means 3. Bute means 4. Pent means 5. Hex, 6. Hept, 7. And we're going to only go as far as octanol because then it becomes a very nonpolar. And that's why these can be liquefied. Okay, so this is how many carbons there are present in each of the substances, and it's the prefix that determines this. So for example, okay, maybe pentanol is in one of our condensation reactions. Pentanol. Pent is the prefix. That means 5. So how many carbons are going to be in pentanol? 5. So, 1, 2, 3, 4, 5. And then you connect them zigzag. And at the bottom and the top of the zigzag represents a carbon. So there would be 1, 2, 3, 4, 5. You don't have to write the carbons, but if you were to write the carbons, they would be here. And every carbon needs 4 bonds, and it only has 2, so there are 2 more implied bonds that we do not write, and those are the hydro as part of the hydrocarbon. So whatever substance or however many bonds are left in each carbon, it is bonded with something, and if nothing is written, then it's just implied that they're bonded with carbons. Okay? So that it can have a full number of bonding pairs can pair. All right, so how do we know? So we know it's pent. We know it's a hydrocarbon with 5 carbons. But how do we know if it's an acid, or if it's an alcohol, or if it's an ester? Well, we have to go a little bit further, and we have to, the H3, okay, our group could be bonded here, but most notably, you would have bonded to this C here, you would have an OH group. And you just draw the OH hanging off it. So because I have a COH group, this is the functional group. That is the functional group, and you need to be able to identify those.